from Team Phoenix, representing Sri Manakula Engineering College, Puducherry, of Team ID 1281443. So, our product name is NeuroCom, which arises from brain communication interface through communicating via our brain to electronic devices, as well as helping people with disabilities to monitor the factors and overcome their disabilities via our product. So, NeuroCom's problem statement arises with people's certain disabilities, which amounts to 15% of the world population. So, there is a wide market existing. We are using electroencephalogram, which is EEG electrodes, and open BCI. In this technical video, the first concept is product demonstration. So, the product we are having are divided into two categories. One are TI components and another are non-TI components. Under TI components, there is a single board BeagleBone AI and ADS 1299, which are under TI components, which are issued up by Texas Instruments. And the non-TI components are EEG electrodes from OpenBCI. In those previous editions, in the first technical video, we demonstrated of how the thoughts are converted into text by our product, and then in the second video, we demonstrated how the system is checking whether the person is telling the truth or the lie. And in this technical video, which is the third one, in this round we will be showing how our product allows a disabled person to use computer, mobile phones and applications like WhatsApp, Instagram, social networking sites and many other applications using brain-computer interface technology, which includes machine learning, artificial intelligence and neural networks. The working of our final prototype would have a test run in 3 stages: acquisition, signal processing and evaluation. Here, the acquisition stage is intended to record data, monitor the EEG signals which is arrived from the user's EEG interface, which would be amplified by USM amp amplifier, which would be converted from analog to digital by ADS 1299, which is a TI component. The active electrodes are placed by International 10-20 system distribution, which is A2, CZ, P3, P4, PO8, PO7 and 2Z, where FPZ is the earlobe connection, which is grounding this entire system. Moreover, a notch of 50 Hz, band pass of 0.1 to 60 Hz and a common average reference filter are applied in the pre-processing stage, which overall give a concluding section for the first stage. In the signal acquisition stage, P300 waves are evoked, which are a component elicited in the process of decision making, which when evoked give control signals, which is exogenous in nature and the large number of commands that can be selected by the user. So here, the P300, if when evoked, gives a certain waves which are used for decision making, which can be utilized by user to select any required operation. In this evaluation procedure, participants are comfortably seated in a panoramic screen view, which is connected to BeagleBone AI, which is used for computation, and thus, when executed, it can be also used as application for smartphones. There are totally 3 stages. There are 2 calibration and 1 evaluation session. So here, by classifying these 3 stages, in the first stage, the user is observed to calculate the optimal parameters and the classified weight vectors and the optimal synchronous threshold. First, users were asked to observe 6 items with 4 trials while flashing the matrix. The second session was intended to record the additional data for robust asynchronous system. And in the third setup, the session was created to assess the usefulness and robustness while assessing the performance of the BCI interface and application. The preliminary results showed that by finishing the 3 stages, we were able to remove the accessibility barrier and the users were able to control smartphones and other electronic devices, and thus it proved to be a successful trial run. When it comes to technical impact, we can be confident that our product is not a product which is similar to other sections. It is completely varied, and the only similarity we can see is that at certain places we have used open source software like OpenBCI and open source EEG electrodes. But their working and our systems working have a little dissimilarity at the signal acquisition mode. And we can observe that in our OpenBCI setup that we created, the main difference is the general traditional OpenBCI module uses 64-bit architecture PCs. That is, only in 64-bit architecture PCs it can be applied. But our module, our NeuroCom's setup is totally dependent on ARMHF architecture and is under single board BeagleBone AI, which is a small on-board computer and doesn't follow a traditional computer's criteria, which allows a major factor of portability. Since our product uses both hardware and software in a customized manner that even in a small board like BeagleBone AI, it works, the portability and accessibility of the function gives high features and thereby giving a high possibility of sale. We have used cutting edge technology like machine learning, artificial intelligence and IoT. Apart from several other variants like brain computing interface. Thank you for your time.
Hey there! I'm here to speak on behalf of the product NeuroCom that was just demonstrated to me. I personally think that this product will help to change the life of people who are differently abled, and it will help them to tend to express themselves through their smartphones just like we do nowadays. I really think that this product should come to the markets, and it will be really helpful for the people who are differently able from us. Thank you.